Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 2-3 lesson on the focus of a parabola. This is going to be a two-part affair here. In this one, we are going to be graphing and writing equations of parabolas using the vertex, which we already know about, and two other things that you may not have heard about called the focus and the directrix. For this lesson, we're going to introduce you to a new form and conception of a parabola called the focus directrix form. At least that's what I'm calling it. In this worldview here, a parabola can be defined as all the points that are equidistant from a focus and a directrix. Now, what are all these things? Well, a focus is just a point, and a directrix is just a line, like this line here. And we're saying the parabola is all the points that are the same distance from this point and this line. Now, the easiest point to pick out, which is exactly halfway between these, is the vertex, halfway between the focus and directrix, right here. And we'll just call this h comma k because we're going to use a formula with h and k in it in a little bit. So we've got this vertex between here, and there's a bunch of other points that are also the same distance from the focus and the directrix. Here's all those other points. It's a parabola. Now, I haven't necessarily drawn this perfectly to scale, but basically this distance here and this distance here should be the same for every single spot on this parabola. Now, the easiest distance to pick out again is the distance from the vertex to the focus or the vertex to the directrix. It's the same distance. We actually have a name for that distance. We're going to call that P. P is the distance from vertex to focus or focus to directrix. It should be the same distance based on the definition of our parabola. So if this distance is P, we can actually write a few kind of mini formulas, one for the focus and one for the directrix. The focus is just going to be basically your vertex plus P. And since this is going vertically, we're going to have to just add P to the K value. So we could call this focus H comma K plus P. The directrix is the horizontal line down here. It's going to be a y equals kind of line. Y equals a number. And that number is just going to be the y value of the vertex minus this p. So y equals k minus p. So I said we'd have a formula where we used all these different letters, at least the h and the k, and the p also actually. Here is that formula. Y equals 1 over 4p, parentheses x minus h squared plus k. This is a little bit intimidating when you first see it, but if you've already seen the vertex form of a parabola, this is basically just vertex form, but instead of an a, we have a 1 over 4p. Now you might wonder, well, why did the stretch factor get swapped out for this 1 over 4p? And I'm not going to prove anything really right now, but the intuition is that the distance between the focus and directrix is 2p, and if you square that, which we do with these quadratic functions here, you end up with a 4 instead of a 2. So I think that's where that 4 is coming from. But moving on, one of the reasons that they have this form of a line is, or form of a parabola rather, is that it can do more than just describe these up-down type of parabolas. It turns out if we swap out all the x and the y stuff in this formula, we can start to describe horizontal parabolas. So another form of this is the one over here. X equals 1 over 4p, y minus k quantity squared plus h. So all the y stuff is inside the squared parentheses. All the x and h stuff is now outside. Total flip-flop, total inverting there. So in this conception here, we have a vertical directrix, like so. The focus is still just a point somewhere on the left or the right of the directrix now. We'll put it over here for now. The vertex is still halfway between our directrix and our focus. So here's a vertex. We'll still call that h comma k. And the distance, and actually here's the rest of the parabola. Let me just draw that in here. There we go. This is kind of neat. It's a left-right parabola, as we said it would be. The distance between the vertex and the focus and directrix, we're still calling that P. But a few things have changed here. Now since we're going horizontally from the vertex instead of vertically, when I get to the focus I have to change the H value rather than the K value. So this is going to be H plus P comma K. The P gets added to the H instead of the K. And to get the directrix, now we're subtracting the p from the h value instead of from the k value. And since it's a vertical line, we have to write x equals h minus p. So whenever we're doing problems, we always have to be wondering, which of these two formulas are we going to be going with? And it's all based on whether we have an up-down or a left-right parabola. So we're going to take everything we just saw about up-down and left-right parabolas in this focused directrix form and see if we can use it to write some equations based on information that they're giving us. Now, this information could take a variety of forms. They might give you a graph like they have here. They might give you the focus, the directrix, the vertex, or some other combination of them. They'll usually give you 2 out of 3 if they're just going to give you this stuff. They might give you both, but rarely do they give you both. This is kind of an exception to that. So the way we're going to start all of these is we need to figure out which formula we're using. Is it going to be the y equals or the x equals? So we're going to pick our formula based on our parabola's orientation. Again, is it an up-down, y equals, or a left-right, x equals? We have a picture here, so I think we can pretty clearly pick out the y equals for that. But there's some other things you can do if they don't give you a picture and you still need to, figure this out without graphing the whole thing. One of these things that you could do is see if x or y is changing. Whichever variable is changing, you're going to write that variable equals for the formula. In this case, that wouldn't be helpful because they gave you a focus and they didn't really give you anything else. I mean, this is a y value here, -2. So if we're changing from 2 to -2, that would suggest it's y equals. Another thing you could do in this situation is you could just see, is the directrix x equals or y equals? And the formula is actually going to match whatever your directrix formula is. So because this is y equals -2, we're going to write y equals and then our formula for the up-down parabola, x 1/4p times x minus h squared plus k. Now this part about x or y changing, that would be more helpful if they gave you the focus and the vertex, and then you could see the y values changing and know that this was the formula we had to go with. Once we've picked that formula, you'll notice that we have to figure out p and h and k in order to actually fill this in. So we need to figure out the vertex and the p-value. And generally, it's going to be easier to find the vertex before p. Now, sometimes they'll give you the vertex. They didn't here. But if they don't, then they've at least got to give you the focus and the directrix. They always give you 2 out of the 3. So if they give you those two things, the vertex, remember, is just the midpoint of those two things, the focus and the directrix. So for this one, I know my vertex is going to have the same x value as the focus, because it's the y values that are changing. So we're going to have 0, comma, and then I just have to average the focus and directrix values together. So we have 2 plus -2 all over 2. And then that's going to just be 0 over 2, which is just 0. So our vertex is 0, 0. Now I could have done this without the graph, but let's just look at the graph and see if I was right. And it looks like, yep, this one is going through the origin. So that works out. So now that we've got the vertex, how do we get the p-value? So there's 2 ways to do it. The p-value, remember, is the distance from the vertex to the focus or directrix. So to find that distance, we need to do a little bit of subtraction. The order of subtraction does make a difference. So we can either do the focus minus the vertex, that's one way to get p, or you could do the vertex minus the directrix, that's another way to get p. You'll want to make sure you do the subtraction in this order. Either always do focus minus vertex or vertex minus directrix. And the reason I say that is because you're going to get a p-value that's either negative or positive, and whether it's negative or positive, you'll be certain that it's the correct sign when you plug it back into this formula if you've done the subtraction in this order. All right, so let's see here. We've got, I'll just do focus minus vertex in this case. So that would be 2 minus the y value 0 in the vertex. So that's just a p-value of 2. Once we've found that, we can just plug that in. Plug in v, plug in the p to this formula here. So we're going to have y equals 1/4 times 2, and then we have x minus 0 squared, which is just x squared, plus another 0 we don't have to write, so really just x squared when all is said and done. And that simplifies to just y equals 1/8 x squared. For this next problem, they again want us to write the equation of a parabola, and this time they've given us a graph with no details about directrix, vertex, or focus. They labeled them in the graph, but they didn't spell it out for us. So if they don't spell it out for you, you're going to want to write the vertex, focus, directrix, whatever they gave you that you can see in the graph. They didn't give us the focus in the graph, but we at least can write the directrix and the vertex. So our vertex in this case would be 0, 0. And our directrix up here, this is the horizontal line through 3, so y equals 3. All right, so we're kind of at the starting point we were at on the last problem, but maybe a little bit wiser. So pause the video and see if you can use this information to write the equation of this parabola. All right, let's see how that went. So step 1, again, is figure out which formula you're using. Just looking at the directrix format here, we have y equals. So our formula should also be a y equals, and the picture shows us this is an up-down one, so again, y equals. Now we need to figure out, let's see here, with the vertex we've already got, so we just need to figure out the p-value at this point. Now to find p, I've got the vertex and the directrix, so we can do vertex minus directrix for this one, 0 minus 3, which gives me the p-value, -3. All right, now we just have to plug that back in. So we have y equals 1 over 4 times -3. And a vertex is 0, 0 again, so this is just going to be x minus 0 squared plus 0, or just simply x squared. So when we simplify this, this all comes out to -1 over 12 x squared. And you'll start to notice some patterns here. When we had y equals positive something with an x squared, our parabola opened up. This negative now makes it open down, which we would expect because just thinking of this as a glorified a value, when a is negative, our parabola is opening down. Here's another example, example 3. This one they're giving us no graph at all, but they are giving us the vertex, 0, 0, and the directrix, x equals 2.5. Pause the video and see what you can do with this one. All right, did you pick out your formula first thing? Since our directrix is an x equals, that's telling us that we have the x equals formula. X equals 1 over 4p, and then y minus k squared plus h. And make sure you're putting k with the y instead of leaving it out there. All right, so a laundry list of things we need. We always need the vertex, and they gave it to us right away. So we already know h and k going to be 0 and 0. Just don't mix them up if they're different numbers. We do need that p-value, though. Since we have the vertex and directrix, we can again do the vertex minus the directrix. So 0, this y value 0, or actually no, it's the x value 0 this time because it's a sideways parabola. So 0, the x value, minus 2.5. That gives us a p of -2.5. Plugging that back into our x equals, we've got 1 over 4 times 2.5, and -2.5 actually. And then we had a y minus 0 squared plus 0, so just y squared. Simplifying that, this is going to be -1 over 10 y squared. We're going to do one more example, writing an equation of a parabola. This time around, the big change is that the vertex, which they didn't spell out, but you can see it here, the vertex is not on the origin. So that's a little bit of a game changer, but I think you can still adjust and focus using the formula you have. So pause the video and give it a shot. All right, so let's start by writing out the vertex and the focus. Our vertex, it looks like, since these grid lines are going by 2's, that's going to be 6, 2. And for the focus, this looks to be 10, 2. Since we can see from the picture that the parabola is left-right, and since we can see from the focus and the vertex that we just wrote that our x values are changing, this is another one that needs the x equals formula for the parabola. And in completing this formula, we've already got the vertex. We'll just have to be careful about plugging that in. So that means we just need to figure out the p-value. So for this one, since we have the focus and the vertex, we can just do focus minus vertex. Just get this distance right here, and we can read it off the graph, but if you do 10 minus 6, you can also see numerically that this is a distance of 4 for the p-value. So plugging all that back in carefully now, we're going to have x equals 1 over 4 times 4. And y minus k, this is the y value of the vertex, so we're going to be doing y minus 2, so be careful in there. And then out here we're going to be doing plus h, so that's the x value of the vertex, so plus 6. And then just to clean that up a little bit more, we can call this 1 over 16 and all this other stuff staying the same. Now, one other thing that's worth pointing out at this point, we had x equals a positive a value, and that gave us a parabola that opened to the right. If we had graphed out the last parabola that had x equals a negative a value, that would have opened to the left. So that whole relationship we saw with the vertical ones of opening up versus down, positive, negative a value, the same thing is true of these sideways ones. Positive opens right, negative opens left. Just good to know. So this is also worth pointing out the end of part 1 of this lesson. So feel free to pause the video, do whatever exercises you need to do, and then come back for part 2, where we're going to be graphing these things and also looking at a real-life application. Welcome back. You're now joining us for the second part of our lesson on parabolas in focused directrix form. On this part, we're going to be graphing some of these. We'll start by graphing this one together. We'll go through it step by step. So if you want to graph the parabola, they said graph it showing the focus and directrix. You'll also want to show the vertex. That's a pretty important piece. So let's start by writing the vertex out based off of this formula here. So we have an invisible kind of x minus 0 squared going on and a plus 0 outside the squared stuff. So we do have a vertex of 0, 0. Next up, in order to get the focus and directrix, if we already have the vertex, we need to add and subtract the p-value to the correct coordinate of the vertex. They're both 0, but we would be using the y value of the vertex because this y equals tells us this is an up-down parabola. So what's the p-value? How do we get that? Well, we know the general formula has 1 over 4p in front of the squared stuff. So what we're going to do is we're going to take this a value that they're giving us in this equation, and to find p, we're going to use 1 over 4p equals that a value. We're going to set up an equation like that. So I'm going to write 1 over 4p equals 1 over 8. Now I just have to solve this for p. If I cross multiply, I've got 4p equals 8, which means then that p equals 2. So let me get my focus now. Again, that's just going to be the vertex plus the p-value. So we're going to have 0, 0 plus 2. So we're using p to find the focus and directrix here. So that's just going to be 0, 2 for the focus, which we'll graph in a moment. For the directrix, we're now doing the vertex minus the p-value. And since it's y equals for the equation, we're going to write y equals for the directrix as well. So we have y equals 0 minus 2, or just y equals negative 2. And now at this point that we have the focus and directrix formulas, we're going to actually graph the vertex, the focus, and the directrix. So here's my grid. My vertex is at 0, 0, so pretty easy to put that on there. For the focus, we've got 0, 2 up here. And for the directrix, we have the line y equals negative 2, the horizontal line going through negative 2. Okay, we need a couple more points in order to actually graph the parabola. Where do we get those points? Now, I guess you could just plug in random x values here. That's absolutely one way to do it. But since you've got 1/8 times these values, it might not come out easily for you. So another way to do this, remember that the way we defined a parabola is it's all the points that are the same distance from the focus and the directrix. So a trick you can use to get points that are the same distance from both, if you start at the focus and you just walk parallel to the directrix, so along this line here, along this line here, you'll always be 4 units away on this problem from the directrix. So if you just keep walking until you're also 4 units away, or however many units from the focus, then you'll end up with a point that's the same distance from both. So just to spell all that out for you, starting at the focus, walk parallel to the directrix in both directions until you are the same distance from the focus and directrix, and then plot the points. So we're 4 away. We go 1, 2, 3, 4 steps this way, and we go 1, 2, 3, 4 steps that way, and now we're 4 away from focus and directrix in both spots. And you can always do that. So let me just draw the parabola now through those 3 points that I just drew, and we've got it. Here's another graphing example for us to try out. Now before we send you off alone to try this here, it's a little bit weird, this one, because it's not in that standard form that we're used to. If this were x equals, then we would have a parabola we could work with, but this is negative 4x equals all this. So how do we deal with this situation? Well, we're going to want to start by putting this in focus directrix form, the form that we've had on the last several problems. And if you're not sure how to do that, remember that both of those forms either start with an x equals stuff or y equals some squared stuff. So really all you have to do is just isolate whatever your linear, your first power variable is. In this case, that's just going to be this x. So if I just get x alone, I will have it in focus directrix form. To do that, I just need to divide both sides by negative 4. So I can rewrite this as x equals negative 1 over 4 y squared. And now this is something that we can graph. Pause the video and take a moment to try graphing this one out. All right, let's see how that went for you. Now just like before, we want the vertex and the p-value so we can get the focus and the directrix. The vertex on this one, we've basically got an invisible y minus 0 squared, so that's a 0 for the y value of the vertex. Another invisible plus 0 out here gives us 0 for the x, so 0, 0. For the p-value, we can set 1 over 4p equal to negative 1 over 4. And if we cross multiply, now we've got negative 4p equals 4, or 4p equals negative 4, however you want to write that. And then dividing by 4 gives us a p-value of negative 1. Now we have to be a little bit careful with this negative 1. We're still going to add or subtract it as we normally would, whichever direction we're going. So to get the focus, again, we're doing vertex plus the p-value, but that really means now we're doing the x value 0 here plus negative 1, which makes it look like we're subtracting 1, but we're really adding negative 1. So that's going to be negative 1 comma 0 for the focus. For the directrix, we're starting with the x value 0 from the vertex and subtracting the p-value, but in this case we're actually going to be adding 1 because we're subtracting a negative. And it's going to be x equals because, again, this is our this is a left-right parabola, so we have a vertical directrix. So we have x equals 0 minus negative 1, or just plus 1. All right, let's graph all this out. We still have a vertex at 0, 0. Thank goodness for that. Focus is negative 1, 0 right there. And now we have a directrix at x equals 1, so that's this vertical line right here. So we can tell from the way this is set up that we're going to be opening to the left with this parabola, which makes sense with this negative that we have in front of the y squared. So let me use my trick of starting at the focus, and I'm going to walk parallel to the directrix to get my other 2 points. Now currently we are 2 away from the directrix, so I just have to take 1, 2 steps up and 1, 2 steps down. So up direction is right there, and 1, 2 steps down gives me that point, and then I just can draw the parabola going through those 3 points. So we're going to give you one more problem where you are going to do some graphing kind of stuff with one of these parabolas, although we're not actually going to do the full graph of this thing. We're just going to identify the vertex, focus, and directrix of this. This is basically everything you would do short of graphing it. And the game changer on this one, you might have noticed, is that, I wrote it up here, vertex not on origin, right? If you look at this clearly, the vertex is not going to be 0, 0. So that's going to force us to adjust a little bit. But I have confidence in you. Pause the video and see if you can get these crucial points based off of this. All right, so let's start by getting our vertex. So the x value of the vertex is going to be this number that we're adding outside here, positive 1. The y value is going to be whatever we're subtracting in here. Remember, it's y minus k for the original formula. So 3 is going to be our y value. So then 1 comma 3 is the full vertex. Now for the p-value, nothing new there. We're just going to do 1 over 4p equals this 1 over 16 a value out here. So that means 4p equals 16 if we cross apply. And that means that p equals 4. To get the focus, we're going to be adding our p-value to the vertex. Since this is a left-right parabola, we're going to mess with the x value of the vertex. We're going to be doing 1 plus 4, comma 3, which gives us 5, comma 3. Now for the directrix, we're going to do that 1 minus 4, and we're going to say x equals that, because it's, again, a left-right parabola. So x equals 1 minus 4, or x equals negative 3. And that's everything they asked for on this problem. All right, so we're going to do one more problem together. You might be wondering at this point why we care about the focus directrix form of a parabola. And this is one of the main real-life applications, is the satellite here. So we have an electricity generating dish uses a parabolic reflector to concentrate sunlight onto a high-frequency engine located at the focus of the reflector. So basically what's happening is all the heat waves, the sunlight waves, are coming into this parabolic dish, and because of the shape of this parabola, they are all bouncing back into this one spot right here. And what is this one spot with relation to the rest of the parabola? Why, it's the focus. It's the mathematical focus. So there you go, real life application. So they're telling us that sunlight heats helium to 650 degrees Celsius to power the engine. We don't really care about that piece of it, but they do want us to write an equation that represents the cross-section of this dish. And they're telling us the vertex is 0, 0. We're on the xy axis right there. And they also want to know the depth of the dish. So let's do first things first. Pause the video and see if you can come up with an equation that describes this parabola-shaped dish here, just the two-dimensional cross-section of it. All right, let's see how that went. So going back to the first part of our lesson here, remember that we have to pick the right equation. Since this is an up-down parabola, we can see that visually. We're going to use the y equals version of our focus directrix form. And just like always, we're going to have to figure out the vertex and the p-value. Now, the vertex is pretty easy. They literally said its vertex is at 0, 0, so I'm just going to write that again for us, 0, 0. So that'll be pretty easy to plug that in. We do need to find the p-value, though. And the p-value is going to be we can do the focus. There is no directrix on this listed, but they did give us this focus up here, this engine. And this focus is 4.5 meters above the x-axis. So that's like 0, 4.5. So to get the p-value, we just need to do 4.5 minus the vertex value of 0, which is literally just 4.5. So there's our p-value. Let's plug that in now. We have 1 over 4 times 4.5. And then plugging in 0 for h and k, this just comes out to x squared, like it has many times before. 4 times 4.5 is, I believe, 18. So this is 1 over 18 x squared. Groovy. Now you might be wondering, okay, how do we use this to get the depth of the dish? Well, keep in mind the depth of the dish is essentially the height of this parabola once you've made it all the way to the very edge here. That's as high as this thing should go realistically. Mathematically, this equation will give us parabola heights that are beyond the dish, but we're not interested in any of those. So we essentially need to ask, how tall is this parabola? What's the height when I plug in whatever this x value over here is? Well, what is this x value? Since this is the distance from the center of the dish to the outer rim here, it's essentially the radius of the dish. So to get the depth, we end up needing to plug in the radius into this formula here. Well, what's the radius? The diameter of the dish given down here is 8.5, so the radius is just half of that, 4.25. So we just need to do 1 over 18 times 4.25 quantity squared. And I'm going to go to Desmos to sort that out. So here we are. We've got 1 over 18 times 4.25 squared. And that comes out to very roughly 1, if we round it off. So we're going to call that about 1 meters deep. So that is it for this one. Hopefully you made it through without any loss of focus. Until next time, this is Mr. Sutton signing off.